Energy use and its increase in consumption is an important topic around the world. Enormous amounts of diesel are burned every year to produce electricity. This is especially the case in remote areas or in areas with an unstable electricity grid. This reliance on diesel could be reduced by using a hybrid solution for electricity generation. Long-term forecasts show that the price of diesel is increasing. However, the price of photovoltaic systems is decreasing, and it is becoming more viable economically to use solar power generation in places with large amounts of sunlight. The same is true with wind-based generation in locations with favorable wind conditions. The return on investment period can be as little as 5 years due to the lower costs of generating electricity using the renewable setup compared to a purely diesel setup. Using the best combination of renewables and diesel gensets ensures fuel savings while maintaining power system reliability. Hybrid applications are suitable for mining and other remote industrial uses, as well as for island and village electrification, remote tourism resorts, off-grid agriculture, and many others. For such applications, ComAp has developed a special controller, Untitled Hybrid. ComAp's hybrid system works by continuously monitoring data from all sources of energy, including solar, wind, or hydro, and gensets. Should the energy production from the source of renewable energy drop below a certain threshold, ComAp's controller automatically starts a backup diesel generator to ensure the continuation of power. The ComAp controller automatically starts, synchronizes, and loads the genset to run smoothly alongside the renewable source. When the energy production from the renewable source becomes feasible again, the system automatically switches to the renewable source and cycles down the generator. For off-grid hybrid applications, ComAp controllers will control the entire power generation setup to match the load. Let's see an example of how ComAp's hybrid system works. There's no solar power generated at night, but the load is also low, so running one diesel generator is sufficient for the load. In the morning, the photovoltaic array resumes producing power. The ComAp system adjusts the output of the diesel genset according to the power generated by the PV array to match the load. As the day progresses, the PV output rises. In this case, the gensets run underloaded. In standard power management, the genset would be stopped, but in this case, this would reduce the reliability of the whole system. The input of the PV setup to the system must be reduced in order to protect the gensets from being underloaded. If the input from the PV array drops, such as in the case of cloud cover, the ComAp controller will automatically load the gensets to keep the power output smooth. When the input from the PV array becomes viable again, the controller will reduce the genset output to utilize as much power from the PV array as possible. Typically, during the afternoon, the PV output decreases, but the load increases. ComAp's controller will start, synchronize, and load more gensets to cover the increased load. This ensures a reliable power supply to all users connected to the power network. There are also hybrid systems which include batteries for storing surplus power generated by the renewable source. ComAp controllers are able to communicate with a battery management system to incorporate batteries into the hybrid system. The ComAp Untitled Hybrid contains a function called Dynamic Spinning Reserve. This function changes the amount of generators running according to the amount of power produced by the renewables to ensure the system can cover a drop in renewable input to the system. The ComAp Untitled Hybrid controller can manage outputs from generators of different sizes, power outputs, and from different manufacturers. The fuel save mode in the controller will automatically choose the most efficient combination of generators to save extra fuel, even out maintenance schedules, and reduce wear on the generators. The Untitled Hybrid also provides an interface to frequency inverters. In case of a genset running under a certain percentage of its nominal load, the controller regulates the inverter output to prevent the engine from running underloaded. Built-in PLC programming, remote configuration and monitoring. Let's summarize the key benefits of the ComAp hybrid control system. It provides system reliability with or without battery storage. Up to 40% reduction in fuel consumption. Extension of generator life and lower maintenance costs, thanks to reduction of generator running hours. Reduced CO2 emissions and other environmental benefits. Use the best combination of renewables and diesel to save fuel and maximize your power system reliability. Use ComAp's hybrid system.